Hello, welcome back to the channel. I hope you really do like the content thus far. In this video, we are going to look at how to find equations of various graphs. This will be the first video. I think we might have about 4 of them, whereby we just look at how to find the equations of different types of graphs. We'll look at linear in this in this video rather. And then the next video will probably look at how to find the equation of parabolic or quadratic graphs, and then that will be followed by finding the equations of hyperbolic graphs. Lastly, we'll look at how to find the equations of exponential graphs. Yeah, so for now, just subscribe and like the video, and maybe even share with your friends so that we can all pass this subject of mathematics. Let's get straight into the video. Suppose you are given what, a graph like this. Okay, just gonna sketch it quickly, and then that is your xy plane, and then the graph it's passing through positive 2 there and negative 4 there. All you need to do is to know that the name of the graph is f, and then that is your xy plane. I'm just gonna use the same colors. Okay, and now all you need to do is to determine the equation of this graph. The graph it's f there, as you can see. So this is a straight line, as you can see. So to determine the equation, the first thing you do is to remember the general equation of a straight line. It's f of x equals to mx plus c. Okay, and you know that c is the y-intercept, and in this case the y-intercept is negative 4. Therefore c is equals to negative 4. And to get now the m, which is the gradient, you must use 2 points, because we are given 2 points. So you must just say y1 minus y2 divided by x1 minus x2. Or you can do it y2 minus y1 divided by x2 minus x1. We just assume that we can just decide which one is the point 1, which one is point 2. So let's call this one point 1, the second one point 2. Okay, and now let's calculate the gradient. y2, we're going to say take it to be 0, and then y1 is going to be negative 4. y2 rather. Okay, but you hear what I'm saying, and not necessarily, you see what I'm writing, not necessarily what I just said. I think I fumbled there. And x2 is 2, x1 rather is 2, and then x2 is 0. Okay, or just to try to avoid unnecessary confusions, write these things as coordinates. The x is 2, y is 0. The other one, the x is 0, y is negative 4. And then you can do the substitution into this formula, and then you'll realize that your gradient is equals to 4 over 2, which is just 2. Then now you have your m, you have your c. Then all you need to do is to substitute back into that equation, the general equation. M is 2, we have x, and then c is minus 4. Then you're done. That's your equation for f of x. Okay, suppose with the same graph, they say to you, you have this situation now, because now you already know the function of f. Suppose we do this. Okay, maybe not the same one. Let's have the second scenario, whereby we have this. Okay, and we have a straight line again, and we have another straight line here. We have 2 straight lines. The 2 straight lines, they are parallel to each other. Okay, the other one is g, the other one is f. This is g, this is f. Okay, you still have your xy plane. I'm not going to keep labeling it going forward. You will see that that is the xy plane. Suppose for f, it intersects with the y-axis at negative 4, but for g, we don't know the coordinates of the intersection. However, we know the equation of g is g of x equals to 2x minus 7. Okay, suppose you have that, and you are now required to determine the equation of f from this scenario. But they told you that f and g, they are parallel to each other. You remember that when you have 2 straight lines which are parallel to each other, that means their gradients, they are equal. That means the gradient of G is equal to the gradient of F, and you can see that the gradient of G is this positive 2 here. That means the gradient of F is also 2. And now, because you are basically looking for the equation of f of x, you must just rewrite the standard equation. It's mx plus c. So you already know what m is. You need the y-intercept. The y-intercept already can tell that for f it is negative 4. That means c equals to negative 4. And therefore, it means that f of x is equals to 2x minus 4. I hope that was easy to do. And maybe the last example for linear I can give you, or maybe the second last, not the last. Suppose you have you have f as it is like that, but instead of g you have maybe h, okay, which is passing through there. You can see that is graph h, and this graph of h, it is the equation which is okay, let me use the right writing. H of x is equals to minus x over 2. That is h of x. That's the equation for h of x. And the scenario is like this. You just have h of x, you also have f, and you are required to find the equation of f, and at the same time you have been told that h is perpendicular to f. Okay, so what do you do in that scenario? In this scenario, you are going to use the perpendicular theorem, which says that when you have two lines which are perpendicular to each other, the product of their gradient is equal to -1. That means the gradient of h multiplied by the gradient of f is equals to -1. So in that fashion, you can therefore now know that because h of x, its gradient is given to you basically because you have the function, and it's going to be -1 over 2, okay, plus the gradient of f, multiply by, not plus, then that whole thing is equals to -1. That means the gradient of f is therefore -1 divided by -1 divided by -1 over 2. You can see that is going to be a positive 2. Okay, I hope you see that. And okay, now we can just rewrite the general function, or maybe usually I would say write this thing first so that you can know what you're looking for. You're looking for c and m, and once you have both, you can just write the equation, then you are done. So you have m already. The c is the y-intercept of f. That means c is equals to -4. Okay, so to write the equation for f of x is just m is 2, and then x plus c, which is -4. Then you are done. I hope getting that equation wasn't complicated. And lastly, when it comes to straight lines, they can ask you, or maybe you might try to find the equation of a straight line when no one was really asking you. Suppose you have a situation like this, and then you have f here, okay, and then it's at an angle of 63.43 degrees from the x-axis, and it still passes through -4, okay, and all you are trying to do is to find the equation of f. Okay, so standard equation, it's this: f of x equals to mx plus c. I always advise you to write the standard equation so that you know what I know. The problem is not that hectic. You are only supposed to get the value of c and the value of m, then you are done. From the situation or the graph, you can tell that c, which is the y-intercept, it's going to be equal to -4, right? And now you are not given 2 points, so you can't calculate m using the change in y over change in x, but instead you are given an angle of inclination. So m is equal to tan of the angle of inclination, which is theta. So now this is how you can get your value of m. That means m is equal to tan of 63.43 degrees. Okay, therefore m is going to be equal to 2. I suppose that's what you will get when you punch the calculator. Okay, then now you can just rewrite the final equation, or write the final equation. It's mx plus c. M is 2x plus c. C is -4 there. Then we are done. I hope you see how easy it is to get the equation of a straight line in these 3 different scenarios. If it still gives you problems, just ask, and then we can always try to assist you. And maybe the problem might be when it gets to the angle of inclination, which is something like this. Let me just address it here in this very same video, because I realized that some students, they still struggle with that. So instead of me waiting for you to ask the question that I can just answer here, let me just answer it here. Yeah, when this is facing in the other direction, and they probably maybe give you the angle this side, and that is probably 63.43 degrees. Okay, that's the angle between the line, and let's call it G, not F. Okay, and then the y-intercept, we still have it as maybe now it's +4. Okay, and we're trying to get the equation of G. The first thing we do again is to say g of x is equals to mx plus c. That is the standard equation. Then we know we're looking for c and m, then we can write the final equation. But c is the y-intercept, therefore c equals to +4 again. And then after that, now we need to know what the value of m is going to be. But you know that m is equals to tan of the reference, the angle of inclination, or the reference angle. Theta is supposed to be the angle of inclination, but in this case they didn't really give us the angle of inclination. They gave us the reference angle. The angle of inclination should be the angle from the positive x-axis all the way to the line itself. So that therefore means that the angle of inclination, which is this theta, plus the angle that they give us, I usually call it the reference angle. They give us 180 degrees, because this is 2 angles which are on a straight line, the black straight line, which is the x-axis. So you can now use this equation to calculate the angle theta that you are then going to use to calculate m. Okay, and this is 63.43 degrees equals to 180 degrees. Therefore theta is going to be equals to 180 degrees subtracting 63.43. okay, and then the angle I get is 116.57 degrees. Okay, hope you also get the same. Therefore m is equal to tan of 106.57 degrees. As a result, m is equals to it's pretty much -1.9999, so we can round it off to -2. Okay, now that you have your m, you have your c, that means g of x is equals to -2x. It's mx, then plus c. What is c? Is 4. Then you see how you get the equation. It's pretty much simple if you were to ask me, but I hope it's also simple for you as well. See you in the next video, whereby we try to find equations of other graphs.